Okay, so we are skipping section 5.3 for now because it's on solving, but before you can solve, you really need to know all of the identities so that you can solve all types of equations that involve all kinds of identities. So I'm skipping 5.3, I'm going to do that last. So we'll do 5.4 today, 5.5 tomorrow. Wednesday will be like a review of those two things. And then Thursday and Friday, we will work on section 5.3, which will be solving trig equations. And then next week, we will have a review on Monday and a test on Tuesday, and then we'll move on to chapter 6. And I think I spelled identities wrong right here. Okay. All right, so first of all, your sum and difference identities. You have this paper that I gave you before what break did we just have? Thanksgiving break. So you have a place to put your sum and difference identity. So in this spot, we need to put our sum and difference identities. And you're going to get to use your identities on your test, and part of the reason for that is because I don't have them memorized any more than you do. Once I work with them a few times, I can tell you what they are, but off the top of my head, I cannot. All right, so for sine, if I'm going to do sine of an angle plus or minus another angle, we can write that as sine of the first angle times cosine of the second. Keep the sign in the middle the same. So if it's plus, it's plus. If it's minus, it's minus. Then we're going to do cosine of the first, sine of the second. All right, cosine is very similar, except that we're going to do cosine, cosine, change the sign, and then sine, sine. So we cosine of the first times cosine of the second, change it to a negative. If you're adding here, this will be minus. If you're subtracting here, this will be plus. If this was written neater, that would make a little more sense. All right, and you're going to do sine of the first, sine of the second. All right, tangents is going to be tangent of the first, keep the same sign, tangent of the second, over 1, change the sign, tangent of the first times the tangent of the second. All right, so those are your sum and difference identities. Make sure you have them written down where you can see them while we're working problems so that they make some sense. All right, we're going to start with just can you do this with simple things from the unit circle. So grab your unit circle if you don't have it memorized, or you can tell me the sign of 45 degrees and things like that. All right, so our directions say use the sum or difference identities to find the exact value. So it says find the exact value. If it didn't say find the exact value, you could type it in your calculator and give me a decimal. But since it says to find the exact value, then you have to give me something usually that has a weird little radical or 2 or 3 in it. And if it's something on a unit circle, you can look it up. If it's not on the unit circle, then we have to figure out how to come up with it. So if I ask you for sine of 75 degrees and I want the exact value, you can't look that up on the unit circle. It's not one that we labeled. It's not an angle that comes from a 30, 60, 90 triangle or a 45, 45, 90. But what we can do is think about 2 things on the unit circle that add up to 75 degrees. So if we say that 75 is the same thing as 45 plus 30, then we have written it as a sum. So we can use the sum identity. So for sine, so look at the ones you just wrote down. It says take sine of the first angle times cosine of the second angle. Keep the sign the same. So since we did 45 plus 30, we're going to add here. Then we're going to do sine of the second and cosine of the first. I think I wrote that backwards from what I had it on your paper. For some reason, that's how I have it memorized in my brain, apparently. So on our paper, we just wrote cosine of the first, because we kept it first angle, second angle. That's what it was. So we'll switch it to cosine 45 sine of 30, which is literally what I just had, and you can multiply in any order, so it would not have mattered, but just so that you're not confused. All right, so now, thinking unit circle. Sine at 45 degrees. The y-coordinate at 45 degrees on the unit circle is root 2 over 2. These are being multiplied. Cosine of 30. So the x-coordinate at 30 degrees is root 3 over 2. Cosine at 45, the x at 45 degrees is root 2 over 2. Sine at 30, the y at 30 is 1/2. All right, so we're going to multiply. We get the square root of 6 over 4. Multiply here, we get the square root of 2 over 4. We can add these because they have common denominators. So you get the square root of 6 plus the square root of 2, which you cannot add, all over 4, and you are done. All right, so not too bad. It's a lot of little pieces, but as long as you have your unit circle to look at and your identities to look at, you should be able to handle it, and you're going to get to use your composition book on your test, and both of those themes are supposed to be in your composition book. Okay, so I want to do cosine of negative 105. There are lots of options on how I can get to negative 105. Okay, so you've just got to pick. Do you want to do negative 60 plus negative 45? Do you want to do 30 minus 135? Like, you can pick whatever as long as it adds up to negative 105. Okay, so I would like to do an example of subtraction. So let's say we do 30 minus 135. All right, so for cosine, you do cosine of both, change the sign, sine of both. So hopefully that makes some sense if you're looking at those identities. So we're going to do cosine of 30 times the cosine of 135. Change it to plus. Then we'll do sine of 30 times sine of 135. All right, so if you look those up on your unit circle, let's see what we're going to get. So cosine at 30 is root 3 over 2. Cosine at 135 is root 2 over 2, but negative root 2 over 2. We change from minus to plus. All right, sine at 30 is 1/2. And sine at 135 is positive root 2 over 2. All right, so now when we multiply those, we get negative square root 6 over 4. And we get positive root 2 over 4. So we get negative root 6 plus root 2 over 4. All right, so you notice your answer to number 1 and your answer to number 2 are pretty similar because everything on the unit circle works off of 1/2, root 2 over 2, root 3 over 2. So you're going to have some combinations of those every time. So you should end up with the same basic answer every time. You're just changing your the order and the signs of things. Okay, so next, let's do a tangent. So let's do tangent of, nope, not a tangent. We're going to do a sine, but with radians, because radians are so much fun. All right, so let's do sine of 5 pi over 12. All right, so 5 pi over 12. So let's think. What can we come up with on the unit circle that's going to give me that? All right, so first of all, let's think of, we got twelfths. We got to add two things together and come up with 5. So can I do like maybe 2 twelfths and 3 twelfths? Will that give me 5 twelfths? It will. So 2 twelfths is 1/6, and 3 twelfths is 1/4, which means I can say this is pi over 6, this is pi over 4, and those are going to add to 5 twelfths. So I can say that sine of 5 pi over 12 is going to be the same thing as sine of pi over 6 plus sine at pi over 4. All right, so sine says do sine of the first times the sine of the second. Keep the sine, that's not true, this is cosine. Trying to do things from memory is not a good plan. Look up your formulas. Okay, so sine of the first, cosine of the second, then we do cosine of the first, sine of the second. And the sign in the middle stays the same, the SIGN sign, plus or minus. All right, so pi over 6 is the same thing as 30 degrees. So sine at pi over 6 is 1/2. Cosine at pi over 4, that's like 45 degrees, so that's root 2 over 2. Cosine at pi over 6 is root 3 over 2. And sine at pi over 4 is root 2 over 2. And again, you can look all of those up on the unit circle. Remember, sine is the y, cosine is the x of the ordered pair. So we get root 2 over 4, and we get root 6 over 4. So our final answer is root 2 plus root 6 all over 4. All right, now for a tangent. All right, number 4 wants us to find tangent of 525 degrees. All right, so first of all, remember that we can use coterminals because an angle in the same place is going to have the same value. So the first thing I'm going to do is subtract 360 if it's more than one rotation and figure out what I'm really dealing with. So 525 minus 360 is 165. That's an easier number for me to think of. All right, so if I break that down, let's see, can I do tangent of like what, 135 and 30? Does that have to be what you come up with? It does not, because on my paper I have 120 and 45. Okay, so it really isn't important. All right, which angles you pick. So like on my paper from where I did it a couple of years ago, I'm looking at my composition book to get the problems, and those are not the angles that I picked. But 135 plus 30 does add up to 60. So we're going to go with those because that's what I wrote down. All right, so the formula for tangent says do tangent of the first angle, keep the same sign, tangent of the second angle, over 1 minus tangent of the first times tangent of the second. Okay, so the sign stays the same, the sign changes. This is just tangent of the angles. Here you're adding them, here you're multiplying them. All right, so we got to see what tangent of each one of these things is. And if you did what I asked you to and wrote down the tangent values on your unit circle, then you should be able to just look them up. So here's what I'm talking about. To make this easier, at the very beginning of chapter 4, we put in a unit circle. We went back one day and we wrote down what the tangent value is at every angle. That's out here outside of the parentheses. So if you didn't do that, pause the video, find your unit circle, and write this down because it's going to make this a lot easier. Okay, so tangent at 135 is -1. Tangent at 30 is root 3 over 3. All right, so the hardest part about all of this is that you have to deal with radicals and fractions and yuck. Okay, so first of all, I'm just going to simplify it to I have -1 plus root 3 over 3. And then this is going to give me a negative, and a negative, and a negative makes it a positive, so it'll be 1 plus root 3 over 3. All right, now we can't leave it with fractions inside of fractions, so I'm going to multiply the entire problem by 3, and that'll get rid of the 3's in the denominator. So it'll be negative 3 plus root 3, and then 30 plus root 3. And then we can honestly leave it there because there's not a whole lot that we can do. We might rationalize the denominator. But if you're going to try to check your answers in the back of the book, they're going to make you do that. Let me think about whether we really want to do this or not. Okay, so to rationalize the denominator, you multiply the top and the bottom by the conjugate of the bottom. So on top, we're going to get negative 9 minus root 3. No, hold on. Negative 9, that would be plus 3 root 3. What I just did. And then plus another 3 root 3. And then minus root 3 times root 3 is the square root of 9, which is just 3. On the denominator, you're going to get 9. You're going to get a negative 3 root 3, a positive 3 root 3, and then a negative root 9, which is 3. So on top, we clean up to negative 9, 10, 11, 12, plus 6 root 3. On bottom, these cancel, you get 9 minus 3 is 6. And then these 3 numbers will all reduce, and you get negative 2 plus the square root of 3. Okay, so on your test, here's the thing. They're probably going to be multiple choice. Okay, so you're going to have to be able to do this step to get to here, or at this point be able to type it in your calculator and figure out the one that matches decimal-wise. On your homework, I want you to attempt to get to this point because it's important that you have this skill, especially if you're going forward in math. Okay, but if you can get to here, you understand the trig. It's going from here to here, where sometimes we fall apart just based on the ability to do the algebra. Okay, so again, to go from here to here, all I did was distribute everything on top and then everything on bottom. Okay, all right, so next up, we have some problems in the directions. Say, find each exact value. But these are not going to be from the unit circle. These are going to be, I'm telling you, I mean, it kind of is based off the unit circle because all of trig is, but they're giving you some values, and you're basically going to be drawing triangles. Okay, so they want you to find the value, and they tell you that you're in quadrant 1. So everything's positive. That's all that means. All right, so number 5, they want cosine of x plus y if sine of x is 4/5 and the cosine of y is 12/13. All right, so the good news is they tend to give you numbers that come from like Pythagorean triples. I couldn't come up with the terms that I was thinking. All right, so if you think of cosine of x plus y, the cosine formula says cosine of the first, cosine of the second, change the sign, so plus becomes minus, and then sine of the first, sine of the second. So from what they gave me, I know that a 4/5 goes here, and I know that a 12/13 goes here. Some of us can picture these triangles in our head and know our Pythagorean triples and come up with the others. Some of us have to draw triangles. It does not matter which boat you're in. So if I draw a right triangle, make this my theta. If we know opposite is 4 and hypotenuse is 5, then this guy is 3. So we know cosine is 3/5. So cosine of x is going to be 3/5. Okay. For y, draw another triangle. They're telling you this is y, so the adjacent is 12. The hypotenuse is 13, which means that this side has to be 5, because that's a Pythagorean triple. So sine of y would be 5/13. All right, so now it's just a matter of multiply. So what is that, 36 over 65? And then here we have 20 over 65. And these are going to generally work out nice and pretty, common denominators, nothing difficult to look at. You subtract, you get 16/65, and you are done. All right, so let's try a tangent one of those. We want tangent of x plus y. And they tell us that cosecant of x is 17/15. And the tangent of y is 3/4. All right, so remember the tangent formula says tangent of the first, keep the sign, tangent of the second, over 1 minus tangents multiplied together. All right, well, we know tangent of y. So we know that this is 3/4, and we know that this one is 3/4. All right, so what we need to figure out is x. So draw a triangle, label x. They told us cosecant. Cosecant's the reciprocal of sine, which means we know the hypotenuse is 17 and the opposite is 15. 15, 17, go with 8. There's a Pythagorean triple, and I just looked that up on the wall in my classroom. Like, I don't have all my Pythagorean triples memorized either. Remember that the Pythagorean theorem will always get you that other side. All right, so if we want tangent of x, we're going to do opposite over adjacent, so 15 over 8. All right, so the tangents are always the ones that are harder and make you think and work more. They just are. All right, so here we go. I need to turn this into something with an 8 on the bottom. So that times 2. I get that 3/4 is the same thing as 6/8. So 15 plus 6 is 21/8. That's my numerator. All right, for the denominator, if I multiply these together, I get 45 30-seconds. So that means I can call the 1 32 30-seconds. So if I do that subtraction, what is that? 13, negative 13. So we have negative 13 over 32. All right, so from our trig identity stuff, we have worked with a fraction divided by a fraction. We know that we're going to do the top times the reciprocal of the bottom. All right, from like elementary school, I know that I can cross cancel. So 8 goes into 8 once and into 32 4 times. So 4 times 21 is 84. And you get negative 13 on the bottom, and you are done. All right, so again, most people fall apart when it comes time to go from here to here to here to here. Okay, so if you have questions about fractions, you can ask them. Just know that that's not the point of the lesson. The point of the lesson is can you do the trig, which is up to this point. And then from here down, that's can you do 4th grade math. If you need help with that, though, please let me know, and I can point you in the right direction for some help. All right, so we learned how to verify. So let's verify with these identities. So 2 more examples will be done. We want to verify each equation is an identity. All right, so number 7 says cosine of pi over 2 minus x is equal to sine x. Okay, so first of all, this is one of the identities that is in your list of identities. It's one of those co-function identities. But to prove it, we can use a sum or difference. So this looks like a sum or difference because it's cosine of two things being subtracted. So if we take our cosine sum and difference identity, we're going to expand this to say cosine of pi over 2 times cosine of x, change the sign, and then it'll be sine of pi over 2 times sine of x. All right, we know that cosine of x is going to stay. We know that sine of x is going to stay. But these two are ones we can get values for. So cosine at pi over 2. Pi over 2 is 90, so the x-coordinate at 90 degrees is 0. Sine at pi over 2, so the y-coordinate at 90 degrees or pi over 2 is 1. So 0 times anything is 0. 1 times anything is that thing. And 0 plus sine is just sine. We got what we were looking for. Yay, we're done. All right, number 8. So the verify, when it comes to sum and difference identities, is really not that bad. But again, tangent is its own little beast. So let's see how you like it. All right, so this is what they give us. So we're going to take this side that looks like the sum or difference identity and expand it. So remember, tangent is tangent of the first. Keep the sign, tangent of the second, over 1 minus tangent of the first times the tangent of the second. The sign changes. On the bottom, the sign changes. Okay, so at 45 degrees, tangent is 1. So our numerator has it fixed. All right. Again, tangent is 1 at 45 degrees. So this is 1 times tangent, which is just tangent. So you have 1 minus tangent, and then you have 1 plus this, which is just tangent. And that is what you wanted. Okay, so your assignment is going to be a worksheet. So it will be attached on the Google assignment. Please let me know if you have any questions. I will attach the answers so you know what they are, but make sure that you show all of the work involved or you will not receive credit.